All right, so we're going to talk about how to write the equation of a line that's perpendicular to another line, given a point that it goes through. Hopefully by this time you have watched the video about how to do this for parallel lines, but now we're going to talk about how to do it with perpendicular lines. It's actually very similar to how we do it with parallel lines, so I'm going to go a little quick in this video. So if you feel like I'm going a little too quick for you, go back and watch that other video. But basically, so here's a question. So write the equation of the line perpendicular to y equals 1/2 x plus 4 that goes through the point 4, 8. And so what I've done here is visually just graphed this for you. So this red line here is this red line. The blue point here just happens to be the y-intercept, which is at 0, 4. And then our goal is to write a line, write the equation of a line that's perpendicular to this red one that goes through this green point. So I'm just going to rough hand sketch this, but basically our line should look something like this. Oh, that was terrible. Let's try that again. It's going to look something like this. So you want it to make a really nice 90-degree angle here, and you want it to go through that green point. Okay? So that's just a rough drawing of what we're looking for. And so let's get started. So to write the equation of a line, I'm going to recommend, again, using point slope form. So y minus y1 is equal to m times x minus x1. I find this the easiest. Even if I have to write the line in slope intercept form, I will start in point slope form. Okay, so let's fill this out. So we're going to do y minus, and then what is the y value of the coordinate of the point that we know that this line goes through? It's 8. So we'll put in 8 there. Y minus 8 is equal to the slope. Okay, m. The slope of this red line is 1/2. Now, before we were trying to write the equation of a line that was parallel to that, so we used the same slope. However, when we do this, we need to use what's called the negative reciprocal. Okay, so what's interesting here is this slope is 1/2. The slope of the line that's perpendicular to that, so 1/2 was that slope. The slope of the line that's perpendicular to that is the negative reciprocal. So what we're going to do is we're going to negate it. So this is positive, so we're going to make it negative, and then we're just going to flip this fraction here. Okay, so the slope of this orange line here that I've done a very rough drawing of has to have a slope of -2/1. So it's going to go down to right 1. So let's fill that in there. So that slope is going to be -2/1. And then that's going to be times x minus whatever the x value of the coordinate is that we're going through. So that's 4. So we'll fill out the 4 here. Okay, and from this point, we're just going to simplify. Oh, that's not what I want to do. Scroll down. All right, so, and I'm going to put this in slope-intercept form. If you like, this is acceptable in point slope form. I would maybe just write -2 there for that red part instead of -2/1, but that's totally fine. Okay, so this will be point slope form. All right, and then to get us into slope-intercept form, I'm going to say y minus 8 is equal to -2 times x minus 4. Let's distribute that -2 there. So we're going to multiply through. So we'll have -2x. If you have -2 times -4, that's going to give you +8. So all I'm doing is multiplying the -2 here and the -2 there. All right, now we're just trying to get y by itself. So let's add 8 to both sides. So +8, +8. And when we do that, we will get y is equal to -2x plus 16. Okay, so that's going to be the exact same line, just in a different form. So this is slope intercept form. If you're not sure, if you come up and graph that line, sure enough, it'll go right through that green point, and it'll be exactly perpendicular to that red line there. All right, let's do one more example, and then I want to talk about a couple weird cases, and that'll be it. All right, so write the equation of the line perpendicular to 2x plus 3y is equal to 12 that goes through the point 3, comma 2. So first thing that I would recommend doing is getting this line here into slope-intercept form just so we can see the slope of this line. So I would recommend subtracting 2x from both sides because we're trying to get the y by itself. So that'll give us 3y is equal to negative 2x plus 12. You could write 12 minus 2x, but I like to put the x first. And then we'll divide by 3 on both sides. And we're left with y is equal to negative 2/3 x plus, and then 12 over 3 is just 4, so we'll just say 4. Okay, so this right here is not our line. This was just the original line that we're supposed to be perpendicular to. Okay, so this is the original line. So I'm going to come up here and go to point slope form. So y minus y1 is equal to m times x minus x1. And I'm just going to start filling some stuff in. So y minus, and what I'm going to put here is the y value of the coordinate that I'm trying to go through. So that would be 2. So y minus 2 is equal to the slope. And okay, so if I want the negative reciprocal of this, so this right now is negative 2/3. If I want the negative reciprocal of that, that's going to be positive 3/2. So you flip the fraction and negate it. Since it's already negative and you negate it, it becomes positive. X minus, and then if we look over here, we're going to want the x value of the coordinate that we're trying to go through, which in this case is 3. So we'll put a 3 in there. This would be totally acceptable for point slope form. This is a great point slope form. If you want slope intercept, that's fine. Let's distribute that 3/2. So we're going to multiply the x and the minus 3 by the 3/2. So we're going to have 3/2 x, and then 3/2 times negative 3 is negative 9/2. And then we're just going to add 2 to both sides here. So add 2, add 2. This is y is equal to 3/2 x. And now we've got negative 9/2 plus 2. I'm going to actually work that out over here. So negative 9/2 plus 2 is the same thing as negative 9/2 plus, I'm going to rewrite 2 as something over 2. Okay, so what would I have to put on the numerator to make this fraction here equivalent to 2? I'd have to put a 4 on top there. So I'm just getting a common denominator of 2 here so that I can actually add these. So negative 9 over 2 plus 4 over 2 is just negative 5 over 2. Okay, so that'll be minus 5 over 2. And this right here is perfect slope intercept form. A little box over here just to separate that. Okay, so either one of these forms is acceptable in my book. Some people like slope-intercept form, but there you go. All right, number 3, write the equation of the line perpendicular to 2y equals 8 that goes through the point negative 1 comma 7. So first of all, let's simplify this line and get it into, let's get the y by itself. So if you divide both sides by 2, you would get y equals 4. That's the equation of our line. So you'll remember that if you have a line like this, that it's a horizontal line. It goes left to right. It's flat. It doesn't go up or down at all. And so when we write the equation of our line, so y minus y1 is equal to m times x minus x1, we're going to need the slope of our new line to be perpendicular to the slope of this line. Let me just draw you a very brief rudimentary sketch of this. So imagine we have the xy coordinate plane here. This is the x-axis, this is the y-axis. Y equals 4 is just this line right here. So let's imagine, this right here is 4. And so basically what we're saying is that no matter what x equals, the y value is always going to be 4. So if you string together all the points where the y value is 4, like here and here and here and here, it would make a horizontal line. We're going to want the slope of our line to be perpendicular to this. So if this is a horizontal line, then we're going to want our slope to be vertical. How do we write the equation of a line that is vertical? Well, it takes the form something like x equals a number. Okay, so let's actually put our point down here. So -1, 7 is going to be like up here. So that point right there is -1, 7. And so what we want is we want our line to be perpendicular to this horizontal line. We want it to meet at a 90-degree angle. That's what it means to be perpendicular. That means we need the slope to be the negative reciprocal. Unfortunately, the slope of the red line is 0 over, you can put whatever number you want. The slope is basically 0. So, 0 over 5, 0 over 10, it doesn't matter. So the slope of the red line is 0. If you take the negative reciprocal of that, then you would do -1 over 0. By the way, the reciprocal, if you just have a number, like if the slope was 3, the reciprocal would be 1/3. Like you just do 1 over that number. The reciprocal of a fraction is just flipping the fraction. So anyway, nice little trick there. In this case, you can't divide by 0. So this is undefined, which means we have a vertical line. And we have ways of drawing vertical lines. People freak out. They're like, oh, I can't do a vertical line. Yes, you can. So the way that this is going to work then for the blue line is we need this to be x equals something. Now, the question is, what should we make x equal? Well, my question is, what does x equal here on this blue line? No matter what point you pick on this blue line, the x value is always -1. Because this is -1 right here, and it just goes up like that. So x equals -1. That's going to be your answer for this. Okay, and last example here. And this one's just the flip of the last one. So on the last one, we had a horizontal line. This one will be a vertical line. So write the equation of the line that's perpendicular to x equals -3 that goes through the point -2, -6. So let's just, again, just a quick sketch of this kind of helps me. So here's the x-axis, here's the y-axis. So we're going to try to be perpendicular to x equals -3. So if you imagine -1, -2, -3 is right there. Our line goes straight up and down vertically here. This is x equals -3. It's a vertical line. And we want our line to be perpendicular to that one, but we also want it to go through the point -2, -6. So -2, -6 is going to be right about there. So that's -2, -6. And we want our line to be perpendicular to this orange line. Well, the only way to get perpendicular to the orange line, since it's vertical, is to go horizontal. And the question is, how do we write the equation of a horizontal line? A horizontal line is going to take the form y equals some number, okay? There's not going to be an x because the slope here is 0. So you're going to get, 0 times x plus a number, which is just whatever that number is. Okay, now the question is, what should we put in for the number right here? So if you look at this point here, what is the y value here? It's -6. What's the y value here? -6. What's the y value here? -6, -6, -6, -6, -6. So the y value doesn't really care what the x value is. It's just always -6. That's your answer.